So now today we will start with some example based on the friction. So let's see the question number 1. A block A weighing 100 kg rests on a block B and is tied with a horizontal string to the wall at C. The block B weighs 200 kg. The coefficient of friction between the block A and B is given as 0.25 and between B and the surface is given as 1/3. The horizontal force P necessary to move the block B should be. Here we have to take the value of G as 10 meter per second square, and our options are: first option is your 1150 Newton, second option is your 1250 Newton, and the third option is your 1300 Newton, and fourth option is 1420 Newton. Now see how to solve this problem. So solution of this problem. See, in this question what is given here? Block A and B, and in the block A, this is block A and this is the block B, and block B has been pulled with a certain force P. That force P we have to exactly determine. And what are the other thing is given? Block A is attached with a string. This point is C. It means block A cannot move. Only the block B has to move, and block B kept on a ground also. So see, between A and B friction is also given. Between B and ground the friction is also given. It means both the point here friction is given. So if block B has to move, it has to be, the force has to be such that it can oppose or it can just balance the minimum the friction force. So let we are making FBD of the block B. So when we are making FBD of block B, so P force is needed. As block B is about to move, then horizontal surface will apply one friction, let this can be said as F1, and ground is applying a normal force, let we can say N1, as well as weight of the block B, let mass of the block B or MB into G. These forces acting now. As the block A kept over the block B, so as soon as block B is about to move in the right side, then the block A will also apply a friction in the left side. So let the block B experience another friction F2 which has been applied by the block A. Other forces, block B, on block B another normal force will exerted by the block A. That normal we can say let N2. So this is the actual FBD of the block B. Now if we are talking about the block A, see, in the block A the forces, first thing is that normal force is action reaction. On block B force your downward N2, so on the block A force will your upward N2. Similarly F2, on block B, block A is applying normal force F2 in the left side, so on block A F2 you are in the right side. Another force on block A, your its weight MA into G. Now since the block A is attached with a string, so that string is also applying a force that can be said as a T, the tension force. So these are the forces acting on a block A. Now we will write the equation for equilibrium. So for block A, Since the block A is not moving, so we can say T is equal to your F2, first equation. It means friction force and tension, these two will balance each other. Now, second, in vertical direction, N2 is acting your upward, MAG is acting in the downward. So, N2 is equal to your MA into G. This is your second equation. This is the for block A. Now, for block B. For block B, if we are looking, the block B does not have any acceleration in the vertical direction. So, downward forces on the block B, your one N2, another downward force your MBG. These two will be balanced by the upward force. So, we can say N1 is equal to your N2 plus MBG. This is the equation number 3. And for horizontal direction, that P we have to calculate. So, in horizontal side, so minimum force for motion of the P, motion of the block B, the B minimum must be your F1 plus F2. So, this is your fourth equation here. And since, important point here, since F1 and F2 are the maximum value needed, or P is the minimum force to accelerate the block B, the F1 value must be equal to your mu 1 into N1 and F2 is your mu 2 into N2. So, these equation we can say equation number 5, and this is the equation number 6, where mu 1 is the friction coefficient between the block B and the ground. Between the block and B ground, mu 1 value is given here 1 by 3, and mu 2 is the friction coefficient between the block A and B, which is given as 0.25. Now, we will just calculate all these values. See, first, from equation 4, 5 and 6, we can say P minimum is equal to your mu 1 N1 plus mu 2 N2. So, now see, from equation 4, 5 and 6, see, so P minimum is mu 1 N1 plus mu 2 N2. So, this is the equation number 7. Now, how to get the value of N1 and N2? N1 is your N2 plus MBG and N2 is your MAG. So, N1 can be said as MA plus NB. So, from equation 2nd and 3rd. So, from equation 2nd and 3rd, we can get N2 is your MAG and N1 is N2 value MAG. So, MA plus MB into G. So, these are the value of N2 and N1, which we will substitute on equation 7. So, finally, we will get P minimum is equal to your mu 1 N1 and mu 1 MA plus MB into G and plus mu 2 N2 value your MAG, mu 2 MAG. Now see the value. Mu1 is your 1 by 3. Mass of block A. Mass of the block A is given 100 kg, while mass of B is given your 200 kg. 100 plus 200, 300. G value given your 10 into 10 plus mu2 given 0.25. Mass of block A is given 100 and G value is again your 100. So this is your 1000 plus this is your 250. So P minimum finally we are having 1250 Newton. So this is the final answer and our option number 2. So answer is your second option is the correct option. Question number 2 is that two masses M1 10 kg and M2 5 kg are connected by an ideal string passing over a pulley. If M1 is resting on a horizontal table which has friction coefficient is 0.2 and M2 is hanging vertically, assuming that the system released from rest, the velocity of each block when M2 has descended by 4 meter, assuming G value of 10 meter per second. This is our question here. And the options are, first option your 17 meter per second, second option your 14 meter per second, third option your 4 meter per second, and fourth option is 3.5 meter per second. Now see how to solve this problem. So according to the question, it is given as there are two blocks. Block M1 is kept on a horizontal table like this, and block M2 is hanging with the help of a pulley like this. This is the block M2, and whole system is released from rest. It is also given mu value, mu between the block M1 and the ground is given 0.2. This is given here 0.2, and masses of the block is also given. Mass M1 is given your 10 kg and M2 is given your 5 kg. So we can substitute write the value of M1 your 10 kg given, M2 is given here 5 kg. So first of all, we would like to find the acceleration of a system. So for that, if we are making FVD, see the FVD for block M2. First we will make for block M2, one force is your M2G downward, that is the gravitational force. Another here on this string tension. This is the forces acting on the block M2G. Now, when we are looking the block M1, this is the block M1, and this block is attached with the same string, and string here your massless. So everywhere the tension on the string will be same, T1. Another force here, as the block have tendency to move rightward, so here friction force, let F. Another force here, reaction by the ground, and fourth force is your M1 into G, its weight. So first thing here, if the block have tendency or moving downward with acceleration A, so block M1 will move in the right side with the same acceleration your A. So for block M2, for block M2, if we are making equation, downward force here m2g, upward force tension minus T. This give you the equation number 1, m2g minus T is equal to your ma. Now, if I am writing for the horizontal for this block, the T minus friction F is equal to your m1 into A, this is your second equation. Now, if it is your sliding, so F is your kinetic friction, and kinetic friction is also given as mu into N. This is the third equation. Now, when we are adding all these three equations, to see what we will get on adding. Another we can say N, normal force here equal to, these are the four equations. So, from equation 1, 2, 3 and 4, from equation 1, 2, 3 and 4, see T and T cancel. If we are adding m2g minus F is equal to your m1 plus m2 into A. Adding first and second equation. On adding first and second equation, we are getting this m2g minus F is your, and F is your mu into N. F is your mu into N, mu is your N is your m1g, so mu is equal to your m1 plus m2 into A. So, acceleration of the block will be m2 minus mu m1 into g by m1 plus m2. So, if we are substituting the value in the acceleration expression, see m2 we got 5 kg, mu into m1, mu value is given 0.2, m1 is your 10, the mu into m1 will be your 2. So, 5 minus 2, g is your 10 by m1 plus m2 your 15. So, finally, we are getting 30 by 15 means here 2. So, 2 meter per second square is our acceleration. It means whole the system is moving with acceleration your 2 meter per second, but we have to find the velocity when the m2 has descended by 4 meter. When m2 has descended by 4 meter, so at this time here velocity, your initial velocity is 0, and whatever the velocity here v, that block also have same velocity v. So, we can use the relation v square is equal to u square plus 2as. V we have to find, that your v square, u square means initial velocity which is our 0 here, plus 2 and a value given here your 2 meter per second square which we have calculated, and s is your from here to here, that your 4. So, v square is your 16, so v is equal to your 4 meter per second. So, this is the answer we got. So, v is equal to 4 meter per second. Which option we can have? In this 4 option, our third option your matches with the answer. So, finally, the answer is your third. Now, see the question number 3. A small block of mass 1 kg is placed over a plank of mass 2 kg. The length of the plank is 2 meter and the coefficient between the plank and block is 0.5, and the ground over which plank is placed is completely smooth. A constant force F is equal to 30 Newton is applied on the plank in horizontal direction. So, the time after which the block will separate from the plank, this we have to calculate. And these times where our options are, first option is 0.73 second, second option is 1.2 second, third option is 0.62 second, and fourth option is 1.6 second. These are our options. Now, see how to solve the problem. See the solution. In the question, they are giving us a plank, and this plank have length 2 meter, and the mass of the plank, let this is capital M, which is given here 2 kg, and this kept on a smooth surface. So, we can say mu for this is your 0. Over this plank, a block of mass, let small m, is your 1 kg has been placed, and here friction coefficient between the block and plank is given here 0.5. Now, question is that if a constant force F is applied, constant force F is equal to your 30 Newton. If we are applying F is equal to 30 Newton, then we have to find the time in which this mass or this block will separate from the plank. It means block has to travel 2 meter distance with respect to plank. So, main point is that block is traveling, it means the block will separate the plank when the block has traveled 2 meter with respect to plank. The key point here, first important key point is this: block will separate from plank when block travels 2 meter with respect to plank. Block travels 2 meter with respect to plank. So, we will make FBD of block with respect to plank. So, first let plank is moving with acceleration A in horizontal direction. Meaning is that if we are making FBD of the plank on which F force is acting, because of that F, here friction force will be there, and some normal is also there, and it's a weight. Here normal N dash, and let plank is moving with acceleration A. So, for plank, first we can say for plank, this is the diagram. So, we can write F minus F is equal to your MA. Now, for block, if we are making FBD, for block, FBD with respect to plank, FBD with respect to plank. So, plank have acceleration this side, So, on block a pseudo force will act MA in this direction and friction will act in this direction. Another force here opposite to that, normal force, and third you can say weight mg. Now, if block is moving in that side with acceleration a dash, so a dash can be said as a, since our FBD is with respect to plank, so a dash is the acceleration of block with respect to plank. This is the acceleration of block with respect to plank. This is important point here. So, now we can make equation for block. For block, one here there is no motion of the block in a vertical direction. So, N is equal to your mg. Let this is equation number 2, and since block we are considering moving in this side with acceleration a dash, equation here ma minus f is equal to ma dash. This is the third equation. And now friction. This friction, since there is a slipping between the block and plank, so this friction your kinetic friction. So, kinetic friction written as always mu into n, mu into n, and this is your fourth equation. So, first we will find the value of a dash, then only we can get the idea how much distance it will travel before falling from the m. So, see, from equation second, third and first C. From equation 1, 2, 3 and 4, check it. How to do? First point, here f minus small f is equal to capital M into A. So, we can write from equation first small a value. So, see, first from first and third. From first and third we can write m, a value from equation number 1 f minus f by capital M, f minus f by capital M minus f is equal to m a dash. Now, we can say small m f by capital M minus m by m, here f, here plus 1 into f, f is your nothing, mu into n, n is nothing, small mg is equal to m a dash. So, see here, a dash is equal to m and m here cancel, f by m minus m by m plus 1 into mu g, substitute the value f by m, f is given 30, capital M 2 minus small m by capital M 1 by 2 plus 1, this becomes 3 by 2, mu value 0.5, 1 by 2, g is your 10. So, finally, we will have 15 minus this we can calculate 30 by 4 or 15 by 2. So, finally, 15 by 2 is the acceleration of the block with respect to plank. So, distance, then we can use the relation This is your meter per second square. So S is equal to your ut plus half a dash t square. So S is the distance which we have to travel, that is 2 meter. Ut initial velocity 0, half a dash value we got here 15 by 2. So 15 by 2 into t square. So from here we can substitute the value, see like this, 8 by 15. So t square is equal to your 8 by 15. This is the value of t square. Then t is equal to your root over 8 by 15, and this is your 0.53, and when we are integrating this one, so that will come around 0.7 second. So this is the answer, t is equal to 0.7 second, and this is the option number 1. First is the correct answer. Now see question number 4. A horizontal and perpendicular to the wall force of 10 Newton is necessary to just hold a block stationary against a vertical wall. The coefficient of friction between the block and the wall is 0.2. Then weight of the block we have to determine. The options are given. First option your 2 Newton, second option your 20 Newton, third option your 50 Newton, and fourth option is 100 Newton. So see the solution of this. The first thing is that, what is the question here exactly? This is your vertical wall and a block. This block is given, and from this side a horizontal force 10 Newton has been applied. So this is the force F, here 10 Newton. So they are asking what could be the minimum horizontal, what could be the force, weight of the block needed to hold this block, and the friction coefficient between the surface of the block and wall is given 0.2. So just make a FBD of the block. So FBD of the block, if we are making, in the FBD we have to show the forces. One is your horizontal force 10 Newton, another your from the wall normal reaction, third is your weight. Let weight of the block is W, which we have to determine. So I am making here question mark here, and because of the weight the block have tendency to go down. So friction force here F. So since to make this block at rest, the minimum value of friction should be equal to its weight. So for equilibrium, F must be equal to weight, and F is equal to your mu into N. Mu value is given here 0.2 and N. And how to get the value of N? See, if we are looking in the horizontal direction, no other forces are acting and a particle is at rest, N must be equal to your 10 Newton. So that is your 10. So friction force is coming here 2 Newton. So our weight, so weight of the block must be, weight of block must be 2 Newton. So which option is correct now? Option number 1 is the correct option. This is our answer. Now see the question number 5. A body of mass 60 kg is pushed up with just enough force to start in moving on a rough surface with friction coefficient, static friction coefficient is 0.5 and kinetic friction coefficient is 0.4 and the force continue to act afterwards. What is the acceleration of the body? So, meaning of this statement is that the body of mass 60 kg is kept on the horizontal surface. So, mass m is given here 60 kg and the friction coefficient, here the two friction coefficient is given, mu s in static which is 0.5 and kinetic friction coefficient given here 0.4. So, what does it mean? First of all, the static friction coefficient means that is the maximum friction we can have, that is mu s into n, and once the body start moving then it will have experience only kinetic friction. So, question in this question they are saying to accelerate this body, minimum force should be equal to your maximum value of static friction. So, see, let F is the applied force. So, to accelerate the body, minimum applied force must be equal to maximum value of static friction, force. So, F minimum must be Fs maximum. So, F minimum must be your mu into n, mu s into n. This is your first equation we can say. Then we will make FVD. So, from FVD, now in this FVD, one is your normal force, another is weight. So, from FVD, n is equal to your mg. So, how much the F minimum is there? This we can say mu s, that is 0.5, n is your mg, that your m is 60, g is your 10. So, this is your 300 Newton we can say. So, to accelerate the body, minimum force is needed here 300 Newton, but they are asking the acceleration. Once the body start moving, then the friction force will be your kinetic friction. So, when again we are making equation like this, right now here in this body, F minimum is acting and this body have acceleration A. At that time friction force your F kinetic. So, equation, if I am writing equation, then it become your F minimum minus F kinetic is equal to your m into A. So, F minimum already we have calculated 300 and F kinetic is always we know mu into n, and here F kinetic mu is 0.4 and kinetic mu mg, m is your 60, n is your, g is your 10, m is 60 into A. So, now simplify here. So, 300 minus 240 is your 60A, which give us A is equal to 1 meter per second square. Now see, from here we can say 300 minus 240 or 60A. So A is equal to your 4 meter per second square. So our answer A is coming 1 meter per second square when we have considered the G value is your 10. If we will consider the G value or 9.8, then the answer will be your A will be your 0.98 meter per second square for G is equal to your 9.8 meter per second square. So our answer of question number 5 is your 4. So option 4 is the correct choice here. Okay, now see the question number 6. A body of mass 2 kg lying on ice which is given a velocity of 6 meter per second is stopped by a friction force in 5 seconds. Find the coefficient of friction between the block and ice if the value of G is given 10 meter per second square. So see the solution of this. The question is that, let this is a block and this block is lying on ice, and when this block has been given a certain velocity v, which is equal to your 6 meter per second and 6 meter per second, there is a friction between the ice and the block. Let the friction coefficient your mu, which we have to determine. Now what they are saying, if the block is moving with velocity 6 meter per second, then because of the friction of ice, the block will come to rest after 5 seconds. So we have to find the value of mu. See, so what is responsible for stopping this block? Definitely there must be a friction force, and that friction force is acting in this direction. So that friction force can produce a retardation. So retardation we can calculate retardation to the block. Retardation to the block A is equal to your F by M, and F is nothing in case of kinetic friction, mu into mg by m. So retardation to the block is your mu into g. So now we can say our block have initial velocity of 6 meter per second, and in this side A is acting your mu into g. Due to this, the block come to rest after 5 seconds. So this is the instant when t0, and here after 5 seconds the velocity of block will be 0. So since A value are constant, we can use our law of motion equation V is equal to your u plus at. So finally V is equal to your 0 final velocity, u is the initial velocity at time t0, which is your 6, and A is acting in the downside backward direction. The A is your mu into g, and time they are saying in the 5 seconds it has been stopped. So this gives us 5 mu g is equal to 6. So mu is equal to your 6 by g value of 10. So this is your 6 by 30, 50, and this is nothing 3 by 25. So mu is equal to 0.12. So this is the option. This is the answer. The mu value is 0.12. So our correct option is third option is the correct option. So answer your third. In the question number 7, a uniform ladder of mass 10 kg leans against a smooth vertical wall making an angle 53 degree. The other end rests on a rough horizontal surface. Then we have to determine these values, N2 value, N1, F, and again another N2 value. See the solution of this. In the question they are saying that this is a wall. On this wall a ladder has been leaned like this, and this angle your 53 degree. From here one force acting your normal N1, from here your N2, this is the weight mg, and since it is sliding here, the friction you are acting in this direction. So we have to determine all these value. The mass of the ladder is given here 10 kg, and let g is equal to your 9.8 meter per second square. Then since the ladder is at rest, so we can write the equation for equilibrium. So at equilibrium horizontal forces are balance each other. So N1 is equal to your F, and vertical forces also balance each other. N2 is equal to your mg. So now substitute the value of m here. So N2 is your m value given your 10, g your 9.8. So N2 is equal to your 98 Newton. The correct answer is your option number 1 for question number 7.